notes, here I am. Take a notebook out, let's start the jam. Video notes, here we go. Take a notebook out, let's start the show. Video notes. Video notes. Hey everybody, welcome to this week's installment of Video Notes for Mr. Flugum's Physical Science class. Thanks for tuning in. Today we're talking about momentum and Newton's third law. These video notes will go on page 19 in your physical science book. Let's get started. Alright, so momentum. Basically, there's no fancy way of putting it. Momentum is just the product of the mass and velocity of an object. Alright, now there's the equation there. P equals m times v. Alright, if you're wondering what in the world is P, well, P stands for momentum. Alright, and they had to choose something other than m because m already stands for mass. Alright, now what are the units for momentum? This is where it gets, well, actually this is actually pretty easy. M is kilograms, right? We always use kilograms for mass. Velocity is meters per second. So, when we're doing momentum, we just kind of smash those two things together. So the units for momentum are kg m / s, kilogram meters per second. Now there's two pieces to momentum, mass and velocity, right? And they're equal in their contribution to momentum. Now, we need to be able to compare momentum, right? Now, let's say we have two objects that have the same speed but different masses. So in this case, we have a trash truck and a pickup truck. They're going the same speed, which has more momentum. Well, the obvious answer is the trash truck, right? The trash truck is going to have more momentum because it has more mass, as long as they're going the same speed. Okay? And this means if you get into a collision, the trash truck definitely transfers more force than the pickup truck. Alright, well, here's another situation. We have two objects that have different masses. For example, a child and an adult. Right? Could the child ever have more momentum than the adult? As you can see on the slide there, yes. If the child has much more velocity, right? It means if the child is traveling faster than the adult, it could have more momentum. Now this is the nice thing about momentum, is that it takes into consideration velocity. This is different than just inertia, right? Where inertia only worried about mass. This also takes into account how fast something is traveling. And we know, we've watched it, right? Things traveling fast can have a big impact on things that they hit or the path that they travel. Alright, so just for review, we've got Newton's third law, right? We've already talked about this in class on Tuesday or Wednesday, whenever you had me. And a couple of examples there, right? A cannon, right? That's why the cannon recoils and goes backwards. And also a rocket, two classic examples of Newton's third law. Now, why are we talking about Newton's third law and momentum? That's because they relate. When a collision occurs, right, when two objects smash into each other, all right, each object exerts an equal and opposite force, right? Okay, so the blue car exerts force on the red car exerts the same amount of force back. What this means is that, the total momentum in the system is going to stay the same. So if both cars have the same momentum, they'll cancel each other out, right? But if one car has more momentum than another, they will continue to move in the direction of the greatest momentum. Let me give you an example with a little math, sorry. Alright, so let's do that math. So we've got those two cars, right? And let's say they both have a mass of 500 kilograms. And the red car's not moving. Now before the collision, blue car has a velocity of negative 10 meters per second. The reason I say it's negative is this, because the blue car is going to the left, which we generally think of as the negative direction. All right? So if we do that, if we find the momentum of the blue car, we go 500, right, times -10. So we get -5,000 kgm/s. Okay, remember kgm/s are the units for momentum. All right. Now after the collision, momentum stays the same. So we just plug that in down here. Let's find the momentum. What's going to happen to those cars after they collide? Well, now the mass has gone up, right? Because you've got two cars instead of one. So we have 1,000 kilograms, right? If we just plug stuff in and divide, we get a velocity of -5 meters per second. So when the blue car hits the red car, that slows it down, right? That's because of Newton's third law, where the blue car exerts force on the red one, but the red one exerts an equal force back. Overall, though, momentum is conserved or kept the same, right? Which means even though there's equal forces, the cars will still continue to move in a negative direction. All right, just at a slower rate because of the forces involved. All right, so here's what you need to know. You need to be able to define momentum. You need to be able to explain how momentum can change, right, by changing the mass or the velocity. We need to be able to compare momentum of objects, all right, different masses, different velocities, and how does that affect things. Okay, we also need to apply Newton's third law, and we've practiced that some, but we need to be able to do it. And then last thing, we need to understand how momentum applies to Newton's third law, which means that whenever something happens, a collision or combining of two masses, that the momentum stays the same. Thanks for tuning in, folks, and I'll see you on Thursday or Friday in class.